$1,000. So this is $13,875 in interest. 1,000, this is $12,268 in interest. If I subtract those two amounts, I find out that the additional interest was $1,607 by being compounded daily rather than annually over 30 years. And I'll next show you how I found these amounts without doing too many calculations. They ask us what's the additional amount earned in 30 years compared to the daily amount compounded daily rather than annually. Let's show you something different. Let's do second and the graph button, the table. And you'll see here that given this x value, this is the y1 value and the y2 value. So let's go down. And y equals 30, and now see it goes beyond that. But here on the y equals 30 row, we'll find out that for compounded annually, it's $13,268, and compounded daily, it's $14,875. This is the future value of investment with continuous compounding. With continuous compounding, we're compounding every time, we're adding on it every second or whatever. It actually approaches the limit. That's where our value E comes from. P dollars are invested for T years at an annual interest rate R, compounded continuously. Then the future value S is given by S equals P times E to the RT dollars. So S equals P times E to the RT. This is continuous compounding. Value of $3,500 invested for 10 years at 9% interest, compounded continually, while you're using S equals P times E to the RT. So the future value will be $3,500 times E raised to the 0.09 times 10. And when I grab my calculator, I find that this value is $8,608.61. We'll round to the nearest penny. How much interest is earned on this investment? Well, the way we find out the interest is we take the future value, and we subtract the original value. So we find out that $5,108.61 was the interest earned on the investment. So that was our S minus P to get the capital I for interest amount in dollars. Now the present value, a lump sum that will give the future value S in compounding periods for interest rate I per period is the present value. So the present value equals the future value divided by 1 plus I raised to the n power. Now remember, I is the annual interest rate divided by the compounding period, and n is the number of compounding periods times the number of years. So just reminding you what those values are. What lump sum must be invested at 9% interest compounded semi-annually for the investment to grow to $15,000 in 8 years? Well, we're using the P equals S divided by 1 plus I to the n. Filling in the values, P equals the 15,000 future value divided by 1 plus. Now I is R divided by K. So 0.09 were compounded semi-annually, so K equals 2. And then we're raising this times KT, or N is KT, 2 times 8. When I grab my calculator, I find out that that is $8,844.96. It's money. We'll be rounding to the nearest penny, and make sure you include that with your answers. We're filling this in. We already told you the answer, but let's show you how to do that on the calculator. We're going to go P equals 15,000 divided by, we'll need parentheses down here. And I'm going to do a double parentheses. We'll see why. First, in the parentheses, we have our 1 plus 0.09, the rate, divided by 2, because we're compounding twice a year. Close the first parentheses. Now I'll raise it to the exponent, and this exponent will be 2 for semiannually times 6 years. And now we can calculate that. That's our $8,844.96.